They are stars at the end of their life, and if they're sufficiently massive, then there's nothing that can stop the collapse. Betelgeuse has captivated astronomers for decades with its unpredictable luminosity fluctuations. These dimming episodes and the star's non-uniform surface features have fueled speculation about veiled stellar processes. Now, the James Webb Space Telescope has revealed what's really behind Betelgeuse, offering new exciting details. Could this revelation finally unlock the secrets of its impending supernova, or will it present even more puzzles about this magnificent supergiant? Join us as we unravel the mystery uncovered by the James Webb Telescope. Stars in the vast expanse of the universe follow a spectacular cycle of birth, life, and eventual demise, each phase unfolding in awe-inspiring ways. One such star that has captivated both astronomers and everyday observers is Betelgeuse, a colossal red supergiant star prominently located in the Orion constellation. Its immense size and ancient age have long intrigued scientists and stargazers alike. Betelgeuse's distinctive reddish hue and fluctuating brightness have been subjects of fascination for generations. However, recent developments have heightened curiosity and concern regarding this cosmic giant. As our understanding of Betelgeuse deepens, we stand on the brink of a potentially momentous event in its cosmic journey. To grasp the enormity of Betelgeuse, one must comprehend its staggering dimensions. This stellar giant dwarfs our Sun by a staggering 764 times. To illustrate its colossal size, envision a star so massive that if it were to replace our Sun, its surface would extend far beyond the orbit of Mars, encompassing Mercury, Venus, Earth, and Mars within its reach. This scale not only underscores Betelgeuse's physical grandeur, but also reveals its current stage in the stellar life cycle as a red supergiant. Betelgeuse is approaching the twilight of its existence. It is undergoing expansion and cooling, a phase that follows the fusion of hydrogen into helium within its core. Despite Betelgeuse's age, estimated to be between 8 and 8.5 million years, in human terms, it stands as an ancient entity in stellar chronology. Over millions of years, Betelgeuse has undergone dramatic transformations, transitioning from a blazing hot blue star to the magnificent red giant we observe today. Stars like Betelgeuse undergo significant changes throughout their lifetime due to the relentless forces of nuclear fusion and gravity. One notable feature of Betelgeuse in its current stage is its distinct reddish hue. This red color results from the fact that Betelgeuse's surface temperature is cooler than that of many other stars, including our Sun. For comparison, the Sun's surface temperature is about 5,500 Kelvin, while Betelgeuse's surface temperature is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that make it appear red. The red color of Betelgeuse is more than just a visual characteristic. It provides valuable insights into the star's physical state and the processes occurring within its vast gaseous mass. Over time, the color of Betelgeuse has shifted, adding to the star's intrigue. Historical records from the Roman and Chinese eras indicate that Betelgeuse was yellow approximately 2,000 years ago. By the 9th century, Arabic astronomers noted its red hue. This color change is not merely a historical footnote, but a significant indicator of the star's evolution. Betelgeuse's changing brightness is another fascinating aspect of the stellar giant. It is classified as a semi-regular variable star, meaning its brightness fluctuates periodically. These variations in brightness have captured the attention of scientists and stargazers for centuries. The star's pulsating brightness adds to its mystique and offers clues about the internal processes and changes it is undergoing. Understanding these changes helps scientists learn more about the life cycles of stars and the complex interplay of forces that shape them. Betelgeuse is known for its variable brightness. Typically, it follows a 400-day cycle and a longer cycle of about 5 years. This behavior was first documented in 1836 by Sir John Herschel. Additionally, Aboriginal oral histories may have noted these patterns even earlier. What makes Betelgeuse truly intriguing is its unpredictability. Unlike many stars that dim and brighten regularly, Betelgeuse sometimes deviates from its usual pattern. This irregularity suggests that complex and not fully understood processes are at work inside the star. Its massive size contributes to these mysterious behaviors. In late 2019, astronomers and stargazers worldwide noticed a dramatic and unexpected change in Betelgeuse's appearance. This event, now called the Great Dimming, caught everyone's attention. Betelgeuse, one of the brightest stars in the night sky and a key feature of the Orion constellation, started to dim significantly. It lost brightness at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest. Normally, Betelgeuse is visible to the naked eye even in areas with considerable light pollution. However, it became much fainter during the Great Dimming, noticeable even to casual observers. This sudden dimming led to widespread speculation and concern among astronomers. Some wondered if the star might be nearing the end of its life and about to explode in a supernova, although this is not expected to happen for another 100,000 years. Monitoring Betelgeuse is challenging due to the time it takes for light from the star to reach Earth. When we look at a star like Betelgeuse, we aren't seeing it as it is now, but as it was in the past. The light we see from Betelgeuse today left the star more than 700 years ago. This means we are always looking at its past, which makes it difficult to predict and monitor rapid changes in its behavior. Andrea Dupree, the deputy director of the Center for Astrophysics at Harvard and Smithsonian, along with her team closely studied Betelgeuse's dramatic events as part of a 3-year project to monitor changes in the star's outer atmosphere. They used the Hubble Space Telescope to observe this enormous star. These observations provided new insights into how a variable star like Betelgeuse functions. Variable stars change in size regularly, leading to variations in their brightness. Researchers were able to examine the layers above the star's surface, which are heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of the Hubble spectra gathered at various intervals between 2019 and 2020 has provided crucial insights into the dynamics of Betelgeuse's upper atmosphere. These spectra predominantly featured 2 magnesium lines, offering a glimpse into the composition and behavior of the star's atmosphere. Researchers discovered a rapid movement of material from the star's surface into its atmosphere, clocking in at approximately 200,000 miles per hour. As this hot and dense material journeyed millions of miles outward from Betelgeuse, it marked the inception of a dust cloud that contributed to the star's diminished brightness during a 3-month outburst. Dr. Dupree and her team estimated that Betelgeuse's southern hemisphere experienced a loss of material at double the usual rate, raising eyebrows in astronomical circles. While all stars naturally shed mass over time, Betelgeuse's accelerated loss caught attention due to its stark contrast with the relatively stable mass shedding of our Sun. This event sparked discussions among astronomers about the potential for a supernova explosion. The substantial release of mass and the subsequent dimming of Betelgeuse prompted considerations of whether this could be a precursor to a spectacular celestial event. Situated approximately 725 light-years away from Earth, Betelgeuse's proximity adds an intriguing layer to the speculation. A supernova explosion of this magnitude would be visible from our vantage point, offering a rare opportunity to witness such an event up close. However, the lingering question remains: does this episode signify an imminent supernova, or is it merely a transient event in Betelgeuse's complex life cycle? Several theories have been proposed to explain this sudden change. One popular theory suggests that during a supernova explosion, there is a stage where a star rapidly transforms. This idea gained traction because many believe Betelgeuse is nearing the end of its life cycle. Another widely held notion is that dust, potentially originating from Betelgeuse itself, could be obstructing our view. It is known that red supergiants like Betelgeuse shed material, which could accumulate into a dense dust cloud blocking the star's light. A third theory considers changes in Betelgeuse's photosphere, the outer visible layer of the star. This theory suggests that alterations in the photosphere's properties could impact how bright Betelgeuse appears to us. To unravel this mystery, researchers employed various observational techniques and conducted detailed spectroscopic studies. The The spectroscopic analysis revealed a decrease in Betelgeuse's effective temperature. This decrease hinted at a significant dark spot on the star's surface, possibly causing the dimming effect. The observed temperature drop of at least 170 Kelvin during the dimming period further supported this hypothesis, indicating substantial surface changes on Betelgeuse. The Hubble Space Telescope, like a vigilant guardian in space, has played a crucial role in unraveling the mysteries surrounding Betelgeuse's peculiar behavior. Through its observations, Hubble revealed that the dimming of Betelgeuse was likely caused by a significant ejection of hot material into space. This material formed a dense cloud of dust that obscured parts of Betelgeuse's surface, resulting in less light reaching Earth. The dust cloud was composed of extremely hot plasma that erupted from a large convection cell on Betelgeuse's surface. As this plasma traversed through the star's hot atmosphere towards its cooler outer layers, it cooled and condensed into dust grains, forming the light-blocking cloud that covered approximately a quarter of Betelgeuse's visible surface, primarily the southern hemisphere. This process is akin to the formation of a vast stellar dust storm, illustrating the dynamic and ever-changing nature of Betelgeuse. This stellar activity highlighted Betelgeuse's convective nature, where massive cells of gas circulate within the star, transferring heat and causing surface disruptions. Such behavior is characteristic of massive stars nearing the end of their lives. The dust cloud persisted for several months before dissipating, allowing Betelgeuse to regain its normal brightness. This event, marked by the interaction between Betelgeuse's stellar wind and the ejected plasma, offers a deeper understanding of the complexities within red supergiants. It underscores the significance of studying stars at different stages of their life cycles to comprehend the broader processes that govern stellar evolution and the eventual fate of stars. While the recent findings about Betelgeuse have provided invaluable insights into its current state and behavior, the star's future remains an open question. The ultimate fate of Betelgeuse, like all massive stars, is to undergo a supernova explosion. This spectacular event will occur when the star exhausts its nuclear fuel, leading to a catastrophic collapse of its core. The subsequent explosion will release an immense amount of energy, dispersing heavy elements into space and contributing to the formation of new stars and planetary systems. The prospect of witnessing a supernova within our lifetime is both exciting and scientifically significant. Such an event would offer a rare opportunity to study the processes involved in stellar death and the creation of cosmic elements. The knowledge gained from observing Betelgeuse's supernova would enhance our understanding of the life cycles of stars and the dynamic nature of the universe. However, the timing of this event remains uncertain. While Betelgeuse is nearing the end of its life cycle, it could still be tens of thousands to millions of years before it explodes. Predicting the exact timing of a supernova is a complex task, given the myriad factors influencing stellar evolution. Nevertheless, the ongoing study of Betelgeuse provides valuable data that brings us closer to anticipating such cosmic events. Scientists are closely monitoring Betelgeuse for any signs of impending changes, using advanced telescopes and observational techniques to track its behavior. The information gathered will not only deepen our understanding of Betelgeuse, but also contribute to broader astrophysical knowledge. As we continue to explore the universe, Betelgeuse serves as a reminder of the dynamic and ever-changing nature of the cosmos. It exemplifies the beauty and complexity of stellar life cycles, offering a glimpse into the processes that shape the universe we inhabit. The revelations about Betelgeuse's recent dimming have added a new layer to its already fascinating story. They highlight the importance of continued observation and study of stars to unravel the mysteries of the universe. With each discovery, we move closer to understanding the intricate dance of celestial bodies and the forces that govern their existence. Stars in the vast expanse of the universe follow a spectacular cycle of birth, life, and eventual demise, each phase unfolding in awe-inspiring ways. One such star that has captivated both astronomers and everyday observers is Betelgeuse, a colossal red supergiant star prominently located in the Orion constellation. Its immense size and ancient age have long intrigued scientists and stargazers alike. Betelgeuse's distinctive reddish hue and fluctuating brightness have been subjects of fascination for generations. Astronomers have studied Betelgeuse for decades, noting its variability in luminosity and the irregularities on its surface. These observations have sparked numerous theories and debates about the underlying stellar processes driving these phenomena. Recent developments in astronomical observation technology, particularly advancements in telescopes like the James Webb Space Telescope, JWST, have provided unprecedented insights into Betelgeuse's nature. JWST's capabilities have allowed scientists to peer deeper into Betelgeuse than ever before, revealing intricate details about its structure, composition, and behavior. To grasp the enormity of Betelgeuse, one must comprehend its staggering dimensions. This stellar giant dwarfs our Sun by a staggering 764 times. To illustrate its colossal size, envision a star so massive that if it were to replace our Sun, its surface would extend far beyond the orbit of Mars, encompassing Mercury, Venus, Earth, and Mars within its reach. This scale not only underscores Betelgeuse's physical grandeur, but also reveals its current stage in the stellar life cycle as a red supergiant. Betelgeuse is approaching the twilight of its existence. It is undergoing expansion and cooling, a phase that follows the fusion of hydrogen into helium within its core. Despite Betelgeuse's age, estimated to be between 8 and 8.5 million years, in human terms, it stands as an ancient entity in stellar chronology. Over millions of years, Betelgeuse has undergone dramatic transformations, transitioning from a blazing hot blue star to the magnificent red giant we observe today. Stars like Betelgeuse undergo significant changes throughout their lifetime due to the relentless forces of nuclear fusion and gravity. One notable feature of Betelgeuse in its current stage is its distinct reddish hue. This red color results from the fact that Betelgeuse's surface temperature is cooler than that of many other stars, including our Sun. While the Sun's surface temperature hovers